Hi everyone, welcome back to USD Bifrost. In the last tutorial, we learned how to create variant sets. This is the structure of the stage that we saved as one layer. We have the print monster with 3 children, the body, the eyes, and the flowers. And the body and flowers are variant sets. Today we'll reference this layer and create assemblies with the USD instancer. A great feature of USD is that you can use it to build a library of assets and reference them at any time, make modifications without changing the original files, and build complex scenes efficiently. The link to all the USD files referenced in this tutorial is included in the description. Without further ado, let's get started. First, let's create a new stage using the node Create USD Stage. Pick a location where you want to save it. Let's name it Monsterland. In this exercise, we'll create 2 layers underneath the root layer, one for the Monster King and one for the crowd. Hover your mouse over sublayers, right-click, under Create Node, select Create USD Layer. Go to the same folder and name it King. Copy and paste the node to create the layer for the crowd. Rename it to crowd.usd. Get an Add to Stage node. Connect the stage to it, and the out stage to the output. Select Maya USD Proxy 1. Go to Attribute Editor and turn Shareable on so that we have direct access to all the USD layers. In the USD Layer Editor, we see that we have the root layer Monsterland and its 2 sublayers King and Crowd. Let's create the King first. To reference a USD file, first we need to open it using the node Open USD Layer. In the Parameters panel, we can select the USD file that we want to open. Let's select this monster.usd, which contains the scene that we created in the previous tutorials. Get a Define USD Prim. Rename the path to King. This will be the container for the monster that we're going to reference. Delete the type here, because this way, whatever type of prim the reference contains, it can be loaded into this prim. Right-click at Reference Definitions and select Define USD Reference. Connect the layer that we just opened to Layer. This sets the layer as a reference and adds its contents to the prim King. To add a prim to a specific layer, we need to specify the layer index in the Add to Stage node. The default layer index is -1, which points to the root layer. We want to add this prim to the first sublayer king.usd, so the index we should provide here is 0. Connect the prim King to prim definitions, and we see our Monster King in the viewport. Let's take a look at the King layer in the script editor. Here's the USD file that we referenced and the path of the parent prim that it contains. Everything contained in this prim is loaded into the prim King. If we go to the Parameters panel of Define USD Reference and change the archetype to Payload, then we can unload or load the reference from the outliner. In this image, we have these butterflies resting on the body of the monster. We can achieve this kind of visual effects using a USD point instancer. Here are the steps that we follow to create USD instances. Scatter points on the surface of a geometry and create instances at these point positions using a prototype. Optionally, we can introduce variations of the sizes and orientations of the instances through randomizing the sizes and rotations of the points. Let's see how to do it in Bifrost. First, we need to get the mesh of the body as the geometry to scatter points on. To get a mesh from a stage, we use the node Read USD Meshes. Connect the stage to it, and we need to provide the prim path where the mesh is stored. Select the king's body in the outliner, go to Attribute Editor, Metadata, and copy its path. Paste the path here. This node returns all the meshes contained in the specified prim as an array. In this case, we only have one mesh in the prim body, so if we connect the output to the node first in array, we get the mesh that we're looking for. Now let's scatter some points using the node Scatter Points. Connect the mesh to geometry, and we can use a combination of a point scope and a terminal to visualize the points. Let's change the scatter mode to blue noise, which gives us a more even distribution than the random option. Set the amount mode to radius so that we can specify the spacing between the points. For the prototype, I've prepared a USD stage that contains a butterfly. We can reference it in the same way as we reference the monster. Copy and paste these three nodes. Change the reference file to butterfly.usd and change the prim path to decoration. To create USD instances, we use the node Define USD point instancer. Let's rename the path to something like instancer decoration. Connect the scattered points to points, and the prim decoration to prototype definitions. Get another Add to Stage node. Connect the current stage to it, and the out stage to the output. We want to add these instances to the layer king.usd, so we enter 0 for the layer index. Connect our instancer definition to prim definitions, and we see the butterflies on the monster king. Go to the Parameters panel of the Define USD point instancer, uncheck Create Default Material, and the instances will have the same material as the reference. I'll talk more about material in the next tutorial. Currently they look too uniform. We can randomize their sizes and orientations using the nodes Randomize Point Scale and Randomize Point Rotation. We can adjust the range of the sizes here. Right now, the butterflies are scattered all around the monster body. What if we want them to rest only in the pink area? Here in the scatter point node, we see this port density weights. This allows us to provide a weight for each vertex of the input geometry by plugging in an array of values or a scalar field. A weight of 0 means that no points are generated near the vertex. If we assign the pink vertices with a weight of 1 and cyan vertices with a weight of 0, we'll have the butterflies only in the pink area. In the last tutorial, we assigned the pink and cyan colors to the mesh vertices. We can retrieve those color values using the node getUSD attribute value. The body of the Monster King is a variant set with 3 variants: noise, gradient, and polka dot. In this case, what we want is the color information of the variant noise. And we need to select this variant in Bifrost before this node can retrieve the values of any of its attributes. To select a variant in Bifrost, we use the node setVariantSelection. Copy the print path of the body and paste it here. Enter the variant set name, which is body color, and the variant name noise. Connect the out stage to the port stage of the getAttributeValue node. Here we need the path of the variant noise. Let's select noise and copy the path from here. We also need to provide the attribute name so that it knows what values to retrieve. If it's the colors of a prim, the attribute name should be primVars::display_color. Set the default type to ArrayMathFlow3. This way, when the node is executed, the output value will be an array of the RGB values of all the mesh vertices. Here I've created a compound that assigns a weight to every vertex based on its color value as well as its altitude. This compound sets a threshold to prevent any point from being generated around the bottom area. For any vertex, if its Y value is lower than the threshold, it will be assigned a weight of 0. For the vertices above the threshold, the pink ones would be assigned a weight of 1 and the green ones a weight of 0. The output of this compound is an array of weights for all the vertices. Connect value to color values, the mesh of the body to geometry, the output weights to the density weights of the scatter point node. And now we have the butterflies landing in the pink area only. And we don't have any attached to the bottom. This setup allows us to easily test different prototypes. For example, we can change the reference. Now we have purple flowers instead of butterflies. We can easily adjust the amount of the instances, the seed, the range of the sizes, etc. We can also quickly apply the same idea to a different variant, for instance, the polka dot. All we need to do is changing the print path in the nodes setVariantSelection and getUSD attribute value, and the pattern will get updated automatically. In the outliner, we can switch to any variant without the instances being affected, because the pattern is based on the selection that we set here in Bifrost. Let's change the selection back to noise. Till now, we're referencing the monster as exactly what it is, but we don't have to. In Bifrost USD, we can change the attributes of a reference without modifying the original USD file. For example, we can replace this noise pattern with a solid color using a defined USD prim, a node that we're quite familiar with. This node, in addition to defining a new prim, can also be used to change an attribute of an existing prim. Copy and paste the prim path of the variant noise. Delete the type, and set the specifier to over. This means any attribute we define here will override the existing attribute of the prim. Right-click Add Attribute Definitions and select Define USD Display Color. Get an Add to Stage node. Set the layer index to 0. And now the noise pattern is replaced by this solid color. With this procedure, we can create all kinds of instances and distribute them based on the attribute values of the reference. We can also easily switch between variants to generate different patterns, and we can change the attributes of the reference to test new designs. Now that we have the monster king ready, let's start creating the crowd. We're going to use the same monster as the prototype and a similar procedure to scatter the monsters, which is generating the points, creating instances from a prototype, and randomizing the sizes and rotations. Here I've made a compound for generating an undulating surface. We're going to scatter some points on this surface and create instances using the reference monster as the prototype. We can just copy and paste these nodes. Let's rename the instance path to instancer crowd. Copy and paste the prim king. Rename it to crowd prototype. Connect the surface to geometry and the prim crowd prototype to prototype definitions. We probably don't want so many monsters, so let's reduce the amount by increasing the radius. Get an Add to Stage node. This time we want to add the instances to the crowd.usd layer, so we enter 1 for the layer index. Connect the instance to prim definitions. And out stage to stage. Now we see a crowd of monsters. We can change the seed of the scattering to have a different distribution. And we can use the same method as we did for the king to change their color attribute. Let's also add the ground surface to the stage under the layer crowd.usd. And we can add a defined USD transform to the Prim King so that we can move, scale, and rotate the Monster King. Now we've completed the USD stage. Let's take a look at the layers in the script editor. In the root layer, we have the addresses of the two sublayers. In the king.usd layer, we have the Prim King and the Prim instancer decoration. The Prim King references the monster.usd file that we created before. And the Prim instancer decoration contains the instances of the purple flowers on the body of the king. In the layer crowd.usd, we have the Prim instancer crowd, which contains instances of the monster that we referenced. It also contains the mesh of the ground surface. If we save the USD stage, each layer will be saved as a .usd file. Here we have the root layer Monsterland and its sublayers King and Crowd. To recap, we referenced the monster.usd file and used a combination of scatter points and define USD point instancer to create USD instances. We also learned how to associate the distribution with attribute values and how to change an attribute of a reference. That's it for today. If you want to know more about the basics of Bifrost USD, such as creating a stage, defining a prim, and creating a variant set, be sure to watch the previous two tutorials in this series. The next tutorial will focus on materials. Thanks for watching, stay tuned, and I'll see you next time.